Thank you, Claude, for this kind introduction. Thank you for having us today. I think that I have to speak very close to the mic because I have been told that people remotely cannot hear if I don't speak very close to the mic. Anyway, so maybe just very small disclosure. This is not a tutorial about AI. It's just to give you a survey on what we have been talking about, what people have been talking about on AI. So there is no equation, no maths there, just I would like to simplified views of the different kind of AI and different approaches, paradigms, and so on. And I'm happy to give this talk together with Juliette today. So we'll do this in two voices, I would say. By the way, we even haven't said who is going to speak about what. So we'll do this spontaneously, if I may say this way. So this one, I think. This is the outline of our talk today. We'll start with a brief overview of the discipline, different approaches, what the so-called the data-driven AI, and then the knowledge-based AI or symbolic AI, and hybrid AI, which is a combination of potentially different approaches of AI. We'll focus a little bit on trustworthiness and responsibility of AI. We'll probably meet what Robert said just before that, and then we will finish our talk with some takeaways. So just this is brief. Maybe a simplistic or simple definition of what is AI is like a automated human-like perceptive and cognitive abilities. An AI algorithm takes data or knowledge or even the notion of information, which still has to be defined here, as input and output, produces a kind of cognitive capacities or cognitive and perceptive capacities, going from sensing to planning, anticipating, and even acting, including understanding and even reasoning and supporting decisions or even taking decisions. And you could have an approach which is totally based on data. This is a quote from The Economist in 2017, which said that the world's most valuable resources is no longer all but data. This has probably to be a little bit mitigated when you think of having knowledge also as a set in the world and in companies, in other organizations, which has to be leveraged also. And Juliette took this quotation from Plato, so this goes back really to old times. A good decision is based on knowledge, not on numbers, and probably that we are in something in between, where a good decision is probably based on a combination of knowledge and data. Again, in a very simple way, if not simplistic way, data-driven approach is probably here to much more dedicated or adapted, I would say, to perception and learning to do a classification, clustering, detection or even prediction on the basis of this data. A symbolic or a knowledge-based approach is much more dedicated to reasoning. By reasoning here, the idea is how to infer new knowledge from a knowledge base, for example, within a context which could be certain or uncertain under a certain number of constraints, and to do probably a certain kind of optimization and to help take a decision in this kind, in this situation. And the hybrid AI, why having this kind of approach which combine both approaches is for different reasons, because in many cases models, explicit models or explicit knowledge already exists, and there is no reason to reinvent the word, to reinvent the wheel, and trying to learn things from data, things which already exist. And also it happens that hybrid AI is probably something which is more explainable, which is also easier to validate, and we'll talk about validation a little bit later when we'll speak about trustworthiness. It is also frugal in terms of data, of course, and it many cases also easy to embed on platforms when you are interested in embedded AI. So we'll talk about this also a little bit later, and probably faster to run also. So let's go a little bit deeper in each of these cases of what is data-driven AI, what is symbolic or knowledge-based AI, and what is hybrid AI. And I hand over to Juliette, who is going to go a little bit into details, and I come back again to give you some insight on what we are meaning by trustworthiness and responsible AI. Juliette.
So, first of all, as mentioned before, each subtopic in AI is suitable for one or for few activities. Mainly data-driven AI, or now machine learning, is very suitable in sense making in order to perceive the situation awareness, eventually to drive the prediction in order to predict the near future, and to give some explanation of the situation, what it is called in military domain, sense making. On the other side, knowledge-based AI, symbolic AI, or hybrid AI is more suitable to support decision, task planning, providing explainability, to support action, which is the implementation of the decision making, and eventually to monitor the overall loop of sensing to action. The main paradigm in AI is there is a lot of paradigm. We spoke about data-driven AI, we spoke about knowledge-based AI, and we spoke about hybrid AI. And each technologies has their main feature. So machine learning and computer vision is more suitable for perception, and you will have a lot of example of machine learning, such as neural networks, such as deep learning, such as convolutional neural networks, and so on. And we will focus on some topics on that. On the other side, knowledge-based AI is for decision-making, reasoning, and you will find some topics such as knowledge-based reasoning, knowledge-based representation through technologies such as semantic networks, conceptual graph, ontologies. You have also reasoning through reasoning engine and reasoning inference. And in that context, there was the expert systems. And last but not least, how to solve combinatorial problems such as planning, scheduling. And we will see some techniques such as constraints programming. And the last part is hybrid AI. And today we spoke a lot of natural language processing, of conversational agents, which mixed mainly machine learning, but also knowledge-based in order to improve the ability to communicate. And in that topic, you will have a large language model, which is the basic of generative AI. Now we will go deeper on data-driven AI, then on knowledge-based AI, then on hybrid AI, and we will see how to use it in trustworthiness approach. Data-driven AI, the spirit of data-driven AI is to use the data in order to build a conceptual model as a baby where his or her mother presents a first apple, a second apple, and then the brain is able to make a conceptual model. As mentioned, we use it a lot for classification, clustering, image detection, object detection in image, recognition, and so on. There are a lot of techniques, neural networks, deep learning, reinforcement learning, but there are also other techniques such as evolutionary algorithm, also called genetic algorithm in the past. Mainly, there are three main approaches. The first one is supervised learning, where you label the data in order to help the inference. There are unsupervised learning, where the model learns by itself, and reinforcement learning, where you can support the learning through awards and penalties. Awards when the model has a good answer, penalties when it has a bad answer. So, going deeper, neural network and deep learning, which is very fashion today, aims to model what's happened in the brain by neural networks. The model is not new, because it was the first computational model was the perceptron in last century, and it used to connect neuron in a neural net, and the main difference between neural network and deep learning is the number of neurons and the number of layers. In the past, when we use neural network, as it was small neural nets, we try to improve the neural nets by first making some pre-processing, and then the neural nets was able to classify or to recognize an object. Now, with deep learning, we are not we need not to have pre-processing, so we can use directly raw data. The main advantage is that you learn from the data, and you can use unstructured data, such as image. But the limitation is, first of all, you need a lot of data. The second point, and you need also to be sure that the quality of the data is good, meaning the data is relevant with respect to the objective of your capacity. And the second limitation is that this kind of model is a kind of black box, so it is not easy to explain why the system answers this answer. We apply it a lot for image processing, for pattern recognition, for prediction, for anomaly detection, for example, in order to use it for diagnostic in maintenance or for predictive maintenance. So here is some application that we made with data-driven AI in Thales. Of course, automatic target detection and recognition use a lot of deep learning approach or machine learning approach. We use it also to detect some object obstacle in a huge picture. We use it also to detect some behavior. Here you have an example of how to detect violent, abnormal behavior on a subway. but we can also use it to detect abnormal behavior on maritime situation awareness. Last but not least, we can use also data-driven AI to predict the time of arrival, to enhance digital sequencer for air traffic management or for biometric recognition. The second main topic is a large language model. Normally, I could put this topic on hybrid AI, but it is mainly based on deep learning. So we put it on data-driven AI. The objective of this technology is to try to predict the next word in a sentence. So it is the flavor of this technology. So we use the people who develop large language model use a lot of deep learning and neural network in order to learn all the text of internet. So there is a lot of capacity to generalize the natural language. But the problem is that you need a lot of data, so it is very dependent to the data set that you use to train. There is a lack of transparency, and you heard a lot of problem about copyright from this kind of generative AI technologies. There is a lack of robustness. Thales has demonstrated that we are able to attack this kind of model very easily. And there is no reasoning inside the processus of generative AI. So it is just statistics and prediction on that. But it is very suitable to generate text, image, and we can use it also to improve the machine learning process by making a completion of the data sets. We can use it, of course, for automatic translation, and you use it a lot, this kind of model. We can use it also to support maintenance by giving some coach or chatbot to help the maintenance operator. And last but not least, we can use it for software code production, because it generates code with some limitation, meaning that be careful. This kind of approach is not necessarily valid. Sometimes it could give some wrong answer. It's not robust. So validity, safety, ethical concern, and robustness could be an issue when you use this kind of techniques. The second part is knowledge-based AI. Knowledge-based AI aims to use symbol and concept in order to reason and to provide an answer. Very suitable to solve complex problem solving through the fact that it is able to represent knowledge and to reason on that. The main technology is semantic nets, conceptual network, ontology, and it's most of time based on logics and mathematics. The advantage that I explained before is most of time they are more interpretable. Explainability is very more easier with this kind of techniques, and it is more flexible. Focusing on the first part, which is knowledge representation and reasoning, which can support, of course, knowledge management, knowledge engineering. So the techniques is on three main approach. The first one is logical representation. The second one is graph, with semantic graph, ontology, conceptual graph, and knowledge graph. Knowledge graph is one of the foundation of Google search. So if you have Google search, it's because knowledge graph exists. And rule-based system called in the past expert systems. So I explained the main advantage. The limitation of this technology is that you have to elicit the knowledge. So to interview some expert, which is which is a rare resource sometimes, it is difficult to handle the uncertainty or the imperfection of the information. And last but not least, the scalability is not so easy to have, especially when you have huge knowledge sets. We use it a lot for information fusion, when you want to combine more semantic information in order to improve situation awareness, such as intelligence. Intelligence could be human intelligence, could be OSINT, open source intelligence, or could be other type of intelligence. The second main knowledge-based approach is how to solve combinatorial problem solving. So one of main approach is constraints programming. Constraints programming aims to solve combinatorial problem, but it's differ to operational research by the fact that the technology splits the modeling of the problem and the solving of the problem. So you have generic solver in order to solve the problem, and you try to model the problem through some constraints, which are logic-based description. The main advantage is that it is very modular. If the problem changes a little bit, you have just to change the model, not to change the overall algorithm. The second main advantage is that it is more intuitive to model that. And we can solve a very huge combinatorial problem. The limitation is that in order to model the problem, you have to know what it is inside the techniques, and sometimes you have to deal with accuracy and completeness of the model. So we use it a lot to solve combinatorial problems, such as resource allocation, when you have a lot of resources to manage under constraints, to solve scheduling problem, mission planning, effect-based operation in military. It is also used a lot for supply chain optimization and for prescriptive maintenance when you want to solve a problem. Some example in Thales, so scheduling for air traffic management. We use it also to support deployments of sensor and effector in a battlefield. We can use it for decision aids, especially to support decision in tactical command and control systems, to improve yield management for manufacturing or for logistics. Last but not least is hybrid AI. Why hybrid AI? It's because, as you see before, data-driven AI and knowledge-based AI have their advantage and their limitation. And the idea is to use a combination of both in order to increase and to use all the strengths of these two approaches. In the future of this presentation, we will speak about hybrid AI as a combination of method and techniques. Methods could be both data-driven AI and knowledge-based AI, but it could be also methods coming from other disciplines such as mathematics, physics, geometry, and thermodynamics, and so on. So it's the same definition as in biology. Hybrid is a combination of two types of discipline. Example of some approaches, of course, no symbolic approach, mixing neural network with symbolic AI. And the previous presentation was mentioned neurosymbolic. There are approaches such as analytical informed neural nets. I will focus more on that after. Of course, graph neural networks and graph embedding, which is the way to also increase the possibility of generative AI. Multi-criteria decision making, I will focus on that. Genetic fuzzy tree is a way to combine fuzzy logic to handle the uncertainty of the information and genetic algorithm or evolutionary algorithm within a decision tree. So it's a combination of three techniques. And I will focus now on one of technology of hybrid AI, which is called analytical model informed neural network, and especially GIN for geometric informed neural network, PIN for physics informed neural network, and TIN for thermodynamics informed neural networks. Each time you enhance or you take into account the property of geometry or physics or thermodynamics within your neural networks in order to improve and to improve the neural nets. For example, if I enhance my neural net with geometry information, I can improve the robustness with respect to some geometric transformation, such as vibration, which is translation, or rotation, or zooming, and so on. So the advantage is that you have more and more robust neural nets. The difficulty is that you have to design this new approach, and it's based on some mathematics, especially algebra, called Lie group. We use it for airborne and space application, especially for automatic target detection and recognition. We use it also in order to support situation awareness based on video surveillance with 360 degrees cameras. And we use it also when we want to make some simulation for electromagnetic. A second approach, it's multi-criteria decision making, which is a completely different approach, but hybrid also. The aim is to support decision making when you have multiple criteria to evaluate or to select some alternative. And this criteria could be conflicting, and normally, most of time, when you are in that kind of problem, you use the weighted sum. The problem of the weighted sum is that if you use it, you have to be sure that each criteria are independent, which is not necessarily the case. So multi-criteria decision-making could support this kind of problem. We develop in Thales an overall methodology in order to aggregate all the criteria with respect to the preference of the decision maker or with respect to the strategy of the decision. The advantage is that it is very explainable. But the limitation is that you need to make some elicitation of the criteria. Each time that you have a multi-criteria evaluation, such as architecture, battlefield architecture, or whatever, threat evaluation and so on, you can use this kind of technology. We can use it also for supply chain management or for healthcare management.
Thank you, Juliette, for this not so deep dive, but nevertheless overview of different approaches of AI. Probably, as I said earlier, it was simplified, but it's simplified just to give you a flavor and a glance on what's going on in this discipline. Now, when it comes to the acceptance of AI by the users, by the be them general public or professionals, the question of trustworthiness and responsibility raises very, very, very fast, if I may say it this way. And in Thales, actually, which is a company operating within critical domains and critical systems, we had to face this issue of trustworthy AI very early, and we proposed actually an approach of what we call trustworthy AI for critical systems now like 6 or 7 years ago. And the motto which summarizes our approach is Thales True AI, where the TR stands for transparent, the U for understandable, and the E for ethical. And I usually say that when Netflix recommends you a movie you don't like, so you just pick up another one and life continues. While if you are taking a flight, provided that 2 aircrafts out of 3 in the world take off or land thanks to Thales systems, because you have kind of flight management systems in the cockpit, or because the aircraft is monitored by an air traffic management system provided by Thales. So if these systems include AI technologies, so it's better that you can trust these technologies. You know, people who are in aeronautics knows very well that in order to embark a software or hardware component on an aircraft for certification, you need to prove that the probability of incident per hour of flight has to be less than 10 power -9 or -6, depending on if you are speaking of the component of the system, which is 0.6 or 9 zeros 1. So it's very, very small. So if you have AI in these systems, so AI has also to comply with these constraints. And so we have based our approach on 4 pillars of this trustworthy AI for critical systems. On 4 pillars, you can see these pillars here: the validity, the security, the explainability, and responsibility of AI-based systems. So by validity, we mean the guarantee that an AI-based systems will do what is meant to do, all what is meant to do, and only what is meant to do. So this, just like in justice, all the truth and only the truth, because you can have a system which does all what is meant to do, but not only what is meant to do. I usually like to tell a story, an anecdote, which struck me. I was a young researcher in AI in mid-90s, I remember, and there was a system which was used by the US Navy to train admirals to steer naval fleets. And the system, it was like a serious game, I would say, a simulator actually. And the system won all the time against the Navy people. And we didn't really understood why or how the system succeeded all the time. And after some reverse engineering, so we noticed that the system actually shot its own ships which were hit, because the system noticed that these ships, the ship which is hit, actually, which is a little bit damaged, decreased, slowed down actually the fleet. So the system just got rid of any ship which were hit, and managed to keep a high speed of the fleet. And it was never said to the system to do that. So the system had just as a kind of the program saying, okay, you should keep a maximum speed of the fleet. Okay, I have to do that. I can shoot ships, so why not mines? And if I shoot mine ships which were hit, so I can keep the fleet going at a high speed. And so this is an example of a system which were not really validated, and it's as you can see here, so validation is as the basis of safety when you're dealing with safety critical systems. And so trust actually has not to be just a declared trust, it has to be proven through different methods on proving that the system is consistent and is valid and is really doing what is meant to do, all what is meant to do, and only what is meant to do. The second demand here, or pillar, which underlies the trustworthiness of AI-based systems, is security, which is actually the guarantee of robustness, of resilience against any kind of malevolent behavior, and especially of cyber attacks. As you know, AI is having a very strong relationship with the cybersecurity. AI is increasingly used to design and implement cybersecurity systems. AI is used also to attack systems, and AI has to be cyber secure. So in Thales we have a team doing what we call cyber friendly attacks. So it's the team actually attacks AI-based algorithms in order to identify their breaches, their vulnerabilities, and to propose countermeasures. And by the way, this team won a challenge proposed by the French MOD a few months ago, and the team managed also, for example, to hack ChatGPT by making ChatGPT provide the recipe of a bomb, for example, so by designing the right prompt to do that. So security is really the second pillar for the trustworthiness of AI-based system. And third pillar is explainability. So Juliette mentioned earlier the black box syndrome, if I may say this way, of data-driven AI algorithms, for example. And very early in the 2015 or 2016, DARPA launched a big program called XAI, Explainable AI, in order to overcome this kind of issue. In Thales, we have also teams working on explainability. So explainability can be a posteriori to provide justification on why a system did what it did or recommended to do what it recommended to do. But we would like to even go further and to design actually self-explainable systems who are able to justify their behavior, to explain their behavior in real time. For example, if you have a digital co-pilot in a cockpit, a digital assistant, which is, by the way, one of the objectives of the ESA, if the digital assistant recommends to the pilot to make a left in 45 miles, for example, so the pilot should be able to ask the question, why should they do that? Especially if she or he had in mind to do something different, and the system should be able to answer because there is a threat or there is a thunderstorm or something like this, which is understandable by a human being, and not because the layer number 3 of the neural net was activated at 30%, which is not an explanation, which is just a trace of the calculation. And if you do this in real time, it means that, for example, if the pilot has 5 seconds to make a decision, so if computing and delivering the explanation take more than 5 seconds, so it just become counterproductive. So the notion of explainability is actually a very tricky issue. It is under reflection also in standardization bodies to understand what does it mean to provide an explanation, because what is an explanation for someone, it's not for someone else. It depends on the context, the language you have to use, the depth of the explanation, and so on. So this is a real issue, but it is really also one of the major pillar also for trustworthiness of AI-based systems. Finally, responsibility. Under responsibility, actually, by responsibility, roughly speaking, we mean the compliance to ethics principles, to regulation frameworks, to laws, and this includes, for example, privacy, data, information privacy. It includes also the reduction of biases in data sets and in algorithms, but it includes also the concerns about the carbon footprint, for example, and the climate change. And we have been working at Thales, we have been working twofold along this line on what we call green AI, which is how to make AI as a digital technology as green as possible, to make it as less energy consuming, if I may say it this way. And also the other aspect is AI for green, how to use AI in order to minimize the carbon footprint of our solutions and applications, especially in aeronautics, for example, where we have different applications and even products. Juliette mentioned earlier the digital sequencer, which is a Thales product actually, optimizing the sequence of aircrafts approaching an airport, for example, in order to minimize the time they spent in the air and thus minimizing their carbon footprint. Another application is the reduction of the so-called decondensation trails. You know, this white trails you can see in the sky when the weather is nice and when you see aircrafts. And these trails actually are greenhouse gas generating, and these gas need to be reduced. Thanks to AI, especially reinforcement learning, for example, as a technique, you can optimize the trajectories because these trails actually depend on the altitude, the humidity, temperature, and so on. And there are recent studies which show that if you accept to consume 5% more of fuel, you can reduce the trail, this condensation trace, by 50%, which is really significant. We have teams also working on what we call the continuous descent, when an aircraft has started its landing approach. because when the aircraft actually descend level by level, they consume more kerosene and more fuel, and if they descend continuously, so you can minimize actually this fuel consumption and thus the carbon footprint. So as you can see here, having this trustworthy AI or responsible AI requires the compliance of a certain number of demands here. We have been working on and which actually raise a certain number of scientific and technological challenges our teams are working on. Just a few words here about the key technologies we have identified in Thales. We spoke about hybrid AI. Frugal AI is the how to minimize the use of data. I would say that big data is no more the sense of history. I mean, the sense of history is really smart data, which means that we need to collect, to store, to process only what is strictly necessary, and stop saying, okay, the more you have data, the more you will be performing. This is like a lazy approach of AI, if I may say it this way. Embedded AI, which is the compliance to what we call the swap constraints, the size, weight, and power constraints here. And in Thales, actually, we have a lot of embedded components on platforms, and we need to work really on this how to make AI algorithms and AI-based systems compliant with very strong constraints to enable the embeddability of these systems on different sensors, radars, sonars, cameras, satellites, aircrafts, and so on. As you can see also, generative AI, which has been making the hype since like 2 years, is just one of the 8 key differentiating technologies here. So, of course, we are working on it, but if you remember the 4 pillars I mentioned, validity, security, explainability, and responsibility, as it is, generative AI doesn't tick any of these boxes. Which doesn't mean that we are not working on it and we are not using it. That just means that we are working on making generative AI also a trustworthy AI. So we have launched a stream which is called True Gen AI in Thales. The objective of this work is to develop, design generative AI-based systems for mission-critical systems. Okay, so maybe I will skip the other examples of AI key differentiating technologies. Juliette, would you like to say a few words on AI engineering? Up.
Just in order to run the time, one of the major also key technology is AI engineering in order to guarantee all this property that David mentioned for a trustworthy AI. We need to develop and to revisit all engineering process and to propose new methods, new tools to support this overall life cycle of systems. We will skip this part due to time, but there is one major program in France called Confiance.ai, supported also with activities coming from the academic part, such as ANITI, such as Sequoia, such as other type of free AI clusters. But there is a main activity for that, and if we want to guarantee trustworthiness during the overall life cycle, we need to revisit this overall process of engineering.
Yes, yeah, this is, AI engineering is not about the innovation in AI, but it is about how to industrialize the process of designing, implementing, qualifying, certifying, deploying, and maintaining AI-based systems. So, and now we've come up with a certain number of tools and methods and processes which enable to do that, and we have started to implement these tools and processes within our engineering workbenches in order to have really an AI engineering process and an AI industrial engineering process. Just one word about regulation. This is the Digital Ethics Charter. Actually, we issued now 2 years ago. We are revisiting it. It comes in 10 commitments. In 10 commitments, as you can see here, a lot of well, the major part of these commitments are about AI, like maintaining human control of AI systems, like designing transparent and explainable AI systems, or like, for example, prioritizing a frugal approach to data. So this is just, I would like to underline the fact that we published this charter at the occasion of our Investor Day, which means that we consider that we are accountable about these commitments and by our stakeholders. And it could even impact Thales shares if we don't meet these commitments. We are working on their implementation now in our processes and in the development processes, especially in engineering, for example. Now, maybe just to jump to the conclusion. There is question. Maybe I can conclude and then we take the question. Huh? Okay. Yeah, just to conclude, I skipped this. You will get the slides, well, at least a revised version of these slides. I skipped this. Just, yeah, the three takeaways would like to maybe to give you is, first of all, of course, as I said, data are assets, but not only. Please keep in mind, especially in aeronautics, that there is a lot of knowledge, there is a lot of expert knowledge, and this knowledge can be leveraged actually to build AI-based systems. So this is very important. AI engineering, we have just talked about it, and of course, one of the challenge is certification of AI-based systems, and finally is the ethics issue. This, I think, it resonates with what Robert said before. So we need to design ethics by design, if I would say, AI-based systems, including the green aspect I mentioned earlier. Thank you for your attention, and I can take some question if there are any. Okay, so the question is, Juliette Mattioli mentioned a lack of robustness in LLMs, therefore Thales showed that it was easy to attack the model. What does attacking a model mean according to the field Thales is working in? Well, attacking the model actually is just trying to find the way to make, for this case it was really ChatGPT, providing information which ChatGPT is not supposed to provide. To find the right prompts, it's not that easy to design this prompt. It takes some time. It takes some time to build a proxy of the system and to try in different ways and to identify this kind of breaches and vulnerabilities. And this is what the examples I mentioned about security. In this case, ChatGPT actually provided the recipe on how to build a bomb, for example, which he was not supposed to do.
So, thank you. Yeah. Thank you, David, and thank you, Juliette. It was a great presentation.